Come back to the Comptia Network Plus course. Routing Protocol Basics. There are two types of routing protocols are used in internetworks. Interior Gateway Protocols IGP and Exterior Gateway Protocols EGPs. IGPs are used to exchange routing information with routers in the same autonomous system AS. An autonomous system is a collection of networks under a common administrative domain, which simply means that all routers sharing the same routing table information are in the same AS. EGPs are used to communicate between multiple ASs. A nice example of an EGP would be Border Gateway Protocol. There are a few key points about routing protocols that I think will be a good idea to talk over before getting deeper into the specifics of each one. First on the list is something known as an administrative distance. So you can see here in figure 10.1 I have a routing flow tree. So here we have the start routing. Here we have routing, static routing, dynamic routing, IGP, EGP, distance vector protocols, RIP1, which is Routing Internet Protocol version 1 and 2, and IGP, which is Interior Gateway Routing Protocol. Here we have link state and protocols OSPF, which stands for Open Shortest Path First, and ISIS means Intermediate System to Intermediate System. And here we have hybrid protocols. EIGRP, which is Enhanced Interior Gateway Routing Protocol, and BGP, which means Border Gateway Protocol. Administrative distances. The administrative distance AD is used to rate the trustworthiness of routing information received on one router from its neighboring router, and AD is represented as an integer from 0 to 255, where 0 equals the most trusted route and 255 the least. A value of 255 especially means no traffic is allowed to be passed via this route. If a router receives two updates listing the same remote network, first thing the router checks is the AD. If one of the advertised routes has a lower advertised AD than the other, the router with the lower AD is the one that will get placed in the routing table. If both advised routes to the same network have the same advised route, then routing protocol metrics like the hop count or the amount of bandwidth on the lines will be used to find the best path to the remote network, and as it was the advertised distance, the advertised route with the lowest metric will be placed in the routing table. But if both advertised routes have the same AD as well as the same metrics, then the routing protocol will load balance to the remote network. To perform load balancing, a router will send packets down each link to test for the best one. Table 10.1 shows the default ADs that a router uses to decide which route to take to a remote network. Table 10.1 Default Administrative Distances. Route Source Default AD. Connected Interface 0. Static Route 1. External Border Gateway Protocol 20. Internal Enhanced Interior Gateway Routing Protocol 90. Interior Gateway Routing Protocol 100. Open Shortest Path First 110. Intermediate System to Intermediate System 115. Routing Internet Protocol 120. External Enhanced Interior Gateway Routing Protocol 170. Internal Border Gateway Protocol 200. Unknown 255. This route will never be used. Understand that if a network is directly connected to the router, will always use the interface connected to that network. Also good to know is that if you configure a static route, the router will believe that the route to the preferred over any other route it learns about dynamically. You can change EDs of static routes, but by default they have an ED of 1. That's the only place above 0, so that you can see why a static route's default AD will always be considered the best route. This means that if you have a static route, an RIP advertised route and an EIGRP advertised route listing the same network, and then by default the router will always use the static route unless you change the AD of the static route. Classes of routing protocols. The three classes of routing protocols are as follows. Distance vector. The distance vector protocol finds the best path to a remote network by judging, you guessed it, distance. Each time a packet goes through a router, it equals something we call hop, and the router with the fewest hops to the destination network will be chosen as the best path to do it. The vector indicates the direction to the remote network. Routing Internet Protocol version 2, and Interior Gateway Routing Protocol IGRP are distance vector routing protocols. These protocols send the entire routing table to all directly connected neighbors. Link state using link state protocols, also called shortest path first protocols. The routers each create separate fields. One of these fields keep track of directly attached neighbors. One determines the topology of the entire internetwork, and one is used as the actual routing table. Link state routers know more about the internetwork than any distance vector routing protocol. OSPF and ISIS are IP routing protocols that are commonly link state protocols. Link state protocols send updates containing the state of their own links to all other routers on the network. Hybrid. Hybrid protocol uses aspect of both distance vector and link state, and formerly EIGRP was the only one needed to understand to meet the Network Plus objectives, but now BGP is also listed as a hybrid routing protocol because of its compatibility to work as an exterior gateway protocol and be used in supersized networks internally. When deployed in this way, it's called Internal Border Gateway Protocol or IGP, but understand that it's still most commonly utilized as an exterior gateway protocol. Distance vector routing protocols. Okay, the distance vector routing algorithm passes its complete routing table contents to neighboring routers, which then combine the received routing table entries with their own routing tables to complete and update their individual routing tables. This is called routing by rumor because a router receives an update from a neighboring router, believes the information about the remote networks without verifying for itself if the news is actually correct. It's possible to have a network that has multiple links to the same remote network, and if that's the case, the AD of each received update is checked first. As I said, if the AD is the same, the protocol will then have to use other metrics to determine the best path to use to get to that remote network. Distance vector uses only hop count to determine the best path to a network. If a router finds more than one link with the same hop count to the same remote network, it will automatically perform what's known as round robin load balancing. It's important to understand what a distance vector routing protocol does when it starts up. In figure 10.2, the four routers start off with only their directly connected networks in their routing table. After a distance vector routing protocol is started on each router, the routing tables are then updated with all route information gathered from neighbor routers. So here you can see figure 10.2, the internetwork with distance vector routing protocols. As you can see in figure 10.2, each router only has a directly connected networks in its routing table. Also notice that their top hop count is 0 in every case. Each router sends its complete routing table, which includes the network number, exit interface, the hop count to the network out to each active interface. Now in figure 10.3, the routing tables are complete because they include information about all the networks in the internetwork. They are considered converged. The top count for every directly connected network remains 0, but notice that the hop count is incremented by 1 each time the path completely passes through a router. So for router 2621A to the path um, to the 172.16.10.0 network still has a hop count of 0, but the hop count for the path to the network 172.16.20.0 is 1. Hop count to networks 172.16.30.0 and 172.16.40 increases to 2 and so on. Usually data transmission would cease while routers are converging, a good reason in favor for fast convergence time. In fact, one of the main problems with routing internet protocol is its slow convergence time. Here we have figure 10.3, converged routing tables. As you can see in figure 10.3, once all the routers have converged, the routing table in each router keeps information about three things: the remote network number, the interface that the router will use to send packets to reach that particular network, the hop count or metric to the network. So I'm going to leave it here today for this video, and thank you very much for listening. And if you liked this video, please consider like, sharing and subscribing. Thank you again.